The story of Apollonius came to me this morning. Apollonius, most people haven't heard of. When he was a young man, somewhere in what's probably Turkey these days, called Turkey, was in a town square. He was maybe 10 years old, and he had a vision. He heard a voice telling him that there was some kind of incredible secret that he could discover. He actually physically started to dig into the earth. He actually discovered some kind of, looked like a tomb, and inside of that there was an engraved plate, which later became known as the Emerald Tablet of Thoth. Apollonius was the name of Apollonius of Tyana, before he became the greatest and the first alchemist of history. Maybe we can't call him the first because we have a tradition of Hermes and of course Thoth and these other beings, but really Apollonius was the guy who found, who rediscovered the Emerald Tablet. This is real history. It's all documented. He found it and he spent years, like almost not sleeping, trying to figure out what these tablets were saying. And when he discovered what they meant, he stopped speaking for 5 years to meditate on what they meant. And what resulted from that was one of the most extraordinary priest, scientist, magician, healers of all time. His name Apollonius of Tyana. Some people, I think mistakenly, because he was around the time of Christ, have said that Christ was a legend based on him, which I don't buy because theology tells us otherwise. But Apollonius was a very powerful figure in terms of showing us what a true alchemist can do. An alchemist is not just a scientist. An alchemist is also ostensibly a healer, a mystic, a priest, all of these things wrapped up into one.
Right.
And so the reason I bring up Apollonius is because you are a scientist, but a few hundred years ago you would have been called an alchemist because you are dealing with the science of that which is not immediately perceptible to human senses. The science of the very, very large, and also the science of the very, very small, which is not apparent to our immediate senses. We can see a kilometer maybe in every direction, but that's the limit of it. We need instruments to see farther, which may be technological instruments, or we need inner instruments of consciousness to see these larger and smaller domains. So I would like to think of you as a modern day alchemist who is reviving the ancient tradition of a science of everything. Would that be a fair way to introduce your work?
Yes, actually, you know, alchemy as well is well known to have an alchemist to have been looking for the ultimate crystal, the philosopher's stone.
The philosopher's stone.
Yes.
Which would do what if you found it, as far as the alchemists were concerned?
Well, there was all sorts of properties to the philosopher's stone. There was healing properties to it. There was transmutation capabilities to it. There was all sorts of associated properties to the philosopher's stone. It had maybe gravitational properties as well, and all this. And so I actually followed some of that through my research, and I'm honored to be thought of as an alchemist. Maybe as a scientist, you know, that wouldn't be appropriate, but actually people like Isaac Newton spent a lot of time doing alchemy, and certainly were considered alchemists.
Oh, Isaac Newton was definitely an alchemist.
Right, and so you know, if I, you know, can rise to that level of science, then I am honored to be part of that group.
It's important to bring it up because I probably think 90% of people think Newton, total left brain scientist. But if you look at the body of his work, what percentage of it was actually concerned with only the immediately material was much smaller than the much more holistic view he had. Many people don't know that he was the first person to suggest that there was a code embedded in the Bible, and because he didn't have computers, he was not able to crack it. But he knew damn well there was something in there that was more than met the eye.
Yeah, actually Newton is known to have studied Kabbalistic text for almost 15 years or 20 years prior to writing any physical laws, and thought that there was a fundamental code in these texts that was giving very specific information about the nature of the universe and the understanding of it and how to apply it. And it led him to even do a replica of the Temple of Solomon, and he believed that there was a code in the way the structure of the Temple of Solomon was built, in what it was meant for, which was to host the Ark of the Covenant, and maybe that there was applications that could be very, very useful to humankind if it could be decoded.
And yet most people now think of people like Newton, the real pioneers of our modern scientific society. Copernicus, Newton. These are the names that immediately pop up, and they think that these people were extremely mechanically minded, that their whole view was mechanistic. But I think that misses important aspects of their personalities.
Absolutely.
And if we don't understand their personalities, how well can we understand the science? And so part of the reason for having a discussion with you is we also have to understand what makes you work to understand your science. You can't separate them. You can't just totally cut off and say, here's the body of work, because there's an individual behind it through which this body of information is coming to us. And so by understanding you better, we can understand your theories, your concepts much better. And that's what we really want to do in the next couple of days, is to find out what brought you to this. And so to begin, I know that in your DVD series you were 9 or 10 and you had some different questions from other people. As all unusual thinkers ask different questions. The questions provide the context for the answer. The answer exists only in relationship to the question.
To the question, yeah.
There is no question to which there is not an appropriate answer, because the answer generates the question and vice versa. We talked about this yesterday. But what was the really centrally powerful question that started to drive you on this alchemical quest? What was the question?
Well, you know, it really started with even earlier than 9 years old, when I would daydream a lot. And as I daydreamed, I looked at the world in a little different way, meaning like the objects that makes up the world, or what we call our reality, would kind of fade away, and a new reality would kind of come to perspective, much more subtle, and it seemed to be based in the space between objects. So by the time I was 9, you know, the major question that had come to me was what kind of dimensional relationship is occurring between objects and the space. And so when I got into my first lesson in geometry, and the teacher went to the blackboard and said, today we're going to learn about dimensions, I got really excited, because I thought he was going to talk about all these worlds I was experiencing. And I was really, really, really disappointed, because what was taught seemed to be incongruent and incoherent with logic. And I tended to be a very logical, and I do still, kind of person. And so when I was, the teacher went to the blackboard, made the little dot, and said, this is dimension 0, and it doesn't exist, I was confused already. I knew I wasn't going to do well in that class, because I could see the dot from all the way from the back of the class, where I was most often placed. I could see the dot on the blackboard. So if it didn't exist, how come I could see it? And so right away, the fundamental axiom of the premise of dimension didn't seem coherent to me. And I started to doubt the validity of the concept. Now, why would that be important? Well, I found out much later on that all of our math and physics are based on these principles, that the dot, the line, the plane, and then eventually the cube produces the third dimension, the dimension that we exist in. However, if the dot doesn't exist, that makes a line that doesn't exist, that makes a plane that doesn't exist. And you take 6 non-existing planes to make a cube, you're not enclosing space. You don't get volume. You get non-existence to the fourth. That doesn't create reality. So for me, there was a fundamental error in that axiom.
It's extraordinary to be able, I mean, of all those children, to have such a fundamental, simple question. If the point does not exist, therefore nothing after the point can exist. Even the teacher doesn't get it, right? Nobody gets it, but you get it. So there must have been a predisposition towards this, which is really a mystery. We don't know why children suddenly see things. But I'm interested in this. You said that you didn't see the world the way that other people saw it. You kind of saw the space in between. And I remember that Don Juan, when he was teaching Castaneda, would say to him, instead of looking at the tree and the branches, I want you to spend the whole day looking at the spaces between the leaves and the branches and see how that shifts your perception. And I think you naturally had that. Can you give us a bit more of an idea of what you were seeing that other people weren't, this space between objects?
Right. It's first of all, I think that it was unusual for me to think, about the question of the dot compared to other kids. But I think it wasn't. I wasn't the only one. I found out later on that actually Buckminster Fuller had the same exact issue early in his childhood when he got to that lesson in geometry. And but Bucky didn't necessarily solve it. He didn't necessarily resolve the issue. He just noted it. And as a child, I was an unusual child. I did have difficulty at school because I was widely uninterested in what was being taught. So I spent a lot of time in my own imagining and staring at objects and looking at nature. I would look out the window a lot. And during those times, there was a whole reality that I was experiencing. I was sensitive to a subtle existence, a subtle set of information, you could say.
Set of information makes sense.
That was present in the space. I could see that objects seemed to have a relationship to the space, that they were not isolated, but I remember one moment specifically when I was in the classroom and I was beside the window and I looked at the tree that was outside, and the tree was maybe 50 feet away from me. And I looked at the tree, and at that moment a voice came in my head and said, what's in between me and the tree? What's that space that I assume is empty? What's going on in there between me and the tree? Are we connected through that space? Is there an exchange of information that's going on? Obviously, I see the tree, so that means that there's some electromagnetic waves that are coming into my eyes and so on. So there's some kind of exchange. I didn't think of it as photons or electromagnetic waves or anything like that, but I could feel that there was some kind of relationship between things and the space that they were in. And so it led me, and maybe it was because I'm highly dyslexic. So I started to think of, things not being I started to think of as things not defining the space, but the space defining the things. Yeah, and so that made it...
That is dyslexic in itself.
Right, exactly.
That's the beginning of your dyslexia.
Right. And so it was, you know, I think it led me into thinking that maybe there may be structure in space, that the space might have structure, it might have a dynamic that eventually produced our reality instead of our reality being isolated from all things.
Isolated and simply defined by the empty, apparently empty space around it.
Right.
Of course, at that age, you weren't thinking in terms of there's some kind of a structure, but you've got the beginnings of a very profound question here that there are no easy answers to. You can't just go up to your neighbors and your friends and say, do you notice this living kind of space around us that seems to have some kind of... Nobody's going to take you on. You're going to be probably pronounced a little bit strange. Dyslexia, yes. This is an interesting point because more and more people are becoming dyslexic, apparently. And it may be that more and more people are beginning to get that juxtaposition from being fixated on the form to becoming more aware of the formless. And it's actually a very oriental idea that you're expressing here. It's something that Japanese would feel very familiar with. Of course, the space not only defines, it informs, and it gives beauty to the environment. That's why we just have one vase in a room, and we don't clutter it with a whole bunch of stuff. So you've got this feeling, you're not having visions, so that we're very clear. You're not having any kind of visions here, but you've got a strong doubt, you've got an important question, and you've not got an answer to what... If we can really bring it down, it is what is space for?
Right.
What is space for? Before we go off into the universe and study cosmology, we have to look at the close things.
Right.
The space around us here in this beautiful environment, the space between us and the trees. So what age did you get to in this inquiry where you started to get a kind of a hook on it and you started to feel, if I pursue this direction, I will maybe get my answer?
Well, you know, later on, actually, some time had passed. I was maybe in my, my teenage years when I realized that atoms, what we call the material world, was mostly made out of space, right? That atoms are made out of 99.99999% space, and that like 0.000001 of a percent of what's going on we call reality. And that's when I start to realize, wait a minute, not only is the space between things an interesting thing to explore, but actually the things that I'm thinking as physical material things in the space is actually made out of no things, made out of mostly space. And the little jiggle, right, of the space that we call energy, electromagnetic radiation, electron clouds, whatever you want to call it, that little jiggle is what makes up our reality. And I start to suspect that we need to look very deeply at what is the space providing to reality. That we couldn't ignore the space. That maybe the 99.99999% of what's there is what's producing the effect that we call reality. And so this combined with when I was about 10 years old, me resolving the problem with dimensions by completely reversing the axiom and assuming the exact contrary, that the dot is the only thing that exists, and that in any dot you could have infinite amount of dimensions, infinite amount of divisions, infinite amount of information, and eventually much later on showing that in geometry you can easily prove that within the context of a finite space, a boundary, you can divide the space to infinity and never exceed that first boundary that you've placed for yourself, so that there's a definite relationship between finite system, boundary conditions, which would define our reality. Any boundary we see, we say, oh, there's a thing, right? Might be a subatomic particle, an atom, a planet, a star, a galaxy. And you know that this different boundary conditions could be infinitely embedded within each other, so that their infinities and boundary condition limitations are related, not separated. And I wasn't clear on that when I was first exploring this. I wasn't clear that I was actually on my way to resolving one of the biggest, most fundamental issue in physics, which is the division between quantum theory and relativistic equations. Relativistic equation defining large objects in our universe, planets, stars, suns, galaxies, universes, and quantum theory describing subatomic particles and atomic structures and all this, and they don't agree. So we don't have a unified view of how the world is made, how the universe functions. And obviously big things are made out of small things, so there must be some kind of continuum between the two. But relativistic equations predict infinities, continuums towards singularity. And quantum theory predicts defined, finite, linear boundaries. And the two don't agree because of that. And I didn't know that at the time, but I was trying to find a solution to have infinite division possibilities and boundary conditions at the same time, right? And I started to find it in geometry, in the way geometry interacts, how geometry can define a space and continuously divide to infinity to give us a very infinite amount of set of information, very complex information from a very simple set of rules that define boundary conditions from infinitely big to infinitely small.
So this is fractals here. We begin to look at fractals. For the average individual, trying to grok the relationship between the theory of relativity on the one hand and quantum theory on the other hand is extremely challenging. Although the question is really simple, and you paraphrased it by large things are made out of small things. So how can it be, if the rules for making small things are different from the rules of making big things, well, how in the hell can you make big things out of small things?
Right.
That's what you just said. Right,
right, exactly.
How can you do it?
Right.
And it's obviously a huge problem.
Right.
At which stage in the process of making small things does it become impossible then to make a big thing out of small things?
Yes.
I have a tree sitting in front of me, which is a fantastic fractal representation of an infinitely tiny little seed, which contains all of that within it. The seed has specific boundaries. It is not without boundaries. It has edges. Within that seed is the potential for a tree which grows fractally. It grows and it branches. The body grows fractally. Our nervous system is a fractal system. 1, 2, 3, 4 branches out.
Right.
Our vascular system is completely fractal. Main pipes, secondary pipes, breaking down until you get to the very, very fine blood vessels at the end of fingers. And we're beginning to see that many objects in our space have fractal capabilities. So you didn't know about fractals at this point when you are asking the question. I'm presuming the word didn't even come up.
Right. I didn't know about it. I was just exploring the relationship between infinities and boundaries. Because remember, I was thinking the only way to solve the axiom of dimensions is to divide the point to infinity.
Yeah.
Right? That the universe made dots, and that each dot could be divided to infinity. So all the scales were available in each point, and that they couldn't be separated. They were all embedded with each other. And I didn't know about fractals, but I could see that there was a potential there to explain something very profound, that the tree that we see had in its potential seed all the information necessary for the tree to grow, for the tree to fruit and make another seed, right? The fractal representation of the previous seed, and that had all the information again. And so these fractal cycles were embedded within each other to infinity, producing all the complexity of our world.
And also to eternity. Because the seed produces the tree, which produces the seed, which produces the tree.
Right.
And there is thus no end. So
That's
you have
right.
an eternal cycle there as well as an infinite cycle.
Right.
But you hadn't really... When did we start using the... I mean, Mandelbrot was talking about fractals.
Right.
He actually used the word fractal.
Yeah, he coined it.
He coined it.
He coined it. Yeah, when his son came from school one day, learning about fractions, he thought, oh, that would be a good way to describe this infinite recursive division of the space, and he came up with the word fractal. Yeah.
So I think that it's fundamental to any understanding of what you say about anything, for people to get a really, really clear understanding that everything that we experience and see in the material world, the visible world, is a fractal structure. Everything in the natural world is a fractal structure. It's not necessarily so when it comes to human creation. But would that be a valid statement that everything has a fractal structure throughout the microscopic to the macro galactic? It is all fractally based. Is that an accurate
statement? In my view, absolutely. That, like, you can't say, oh, I'm going to divide the atom and find some fundamental particle and say, oh, that particle can no longer be divided.
Yes.
No, you can always build a larger accelerator, and you can always collide that particle at a faster rate and get a smaller and smaller and smaller particle. And every time we find such a smaller particle, we think that's the end.
Yes.
And then eventually somebody comes up with a new equation and says, oh no, there might be something below that. And if we built an accelerator that a little bit bigger with a little bit more energy, we should be able to find it. And so we keep building larger and larger accelerator. Now we've reached practical limits, right? The Hadron Collider in Switzerland, 17 mile long, goes through 3 countries, cost, I think at this point, $12 billion. It's enormous. It's probably the largest accelerator that can be built practically. And, we're looking for a particle that's billions of times smaller than the atom when only, a few generations ago, we discovered the cell and thought that the cell was the smallest thing.
Exactly.
And then we discovered the atom and thought that was the smallest thing. And then we discovered the protons and thought, oh my God, that's so small. It must be the smallest thing. That's the God particle. And then again and again and again. So, now we're billions of times smaller than the atom. Are we actually going to find a God particle? Probably not. Mm-hmm. And so my view is, no, we should stop looking for some fundamental particle and start paying attention to the pattern of divisions, the structure under which it divides. We did the same thing in the other direction. We thought the Earth was the biggest thing in the universe, because we didn't have telescopes and all this. Eventually we realized, oh my God, the sun is so much bigger than the Earth. The Earth is like a little grain of sand beside the sun. And then we said, oh, that's got to be the biggest thing. And then we found, oh, the sun is actually a small star compared to the other stars. They're much larger. And we discovered the galaxy. And we said, oh, that's so big. There's billions of star system in the galaxy. That must be the biggest thing the universe does. And then we found, galactic clusters. And we see, and we found that there's billions of galaxies and all this. And now we think, oh, the universe is the biggest thing the universe does. Well, I would tend to suspect that our universe is embedded in a larger one, and in a larger one, and in a larger one. So, in that sense, it becomes
You have infinite regression.
Yeah, yeah.
Infinite progression and infinite regression.
Right.
It never ends.
It never ends. You have infinite iterations. And so what would be important for human beings to understand is not necessarily how big or how small something is, but how does the universe divides the space?
Yes.
What are the parameters that produces the division? Because if we understand those parameters, then we would have the key to creation.
Yes.
And we can become co-creators in the division of the space.
So how does the information which is behind the fractal division of space, there must be an informational field which is actually doing all of this.
Right.
It's not just happening. You can't really conceive of a random process by which you have perfect replication at all levels of creation being some kind of an accident must be a candidate for a mental asylum to seriously consider that as a scientific proposition from a layman's point of view.
Right.
How could you think that? How could you think that a tree accidentally became a tree when seeds have for millions of years been producing that pattern?
That's right.
So this pattern that you're talking about is a direct result of you having noticed the space between things. You're looking at things from an entirely different perspective. Let's look at the pattern behind creation rather than find the particle that makes it all happen.
Right.
You're looking for something different.
Right.
You're looking for a pattern.
I started to look for a pattern in space, which led eventually to a paper I written with my co-author, Dr. Elizabeth Rauscher, where we showed a scaling law. So in the scaling law graph, we show that there is order in the way the universe divides, right? All the data points, if we take the data of various objects from universal size to galactic to quasars to stellar systems, atomic structures, subatomic particles, all these, if it was dividing in random ways, would be all over the place on that graph, but they are not. They produce a very accurate linear progression on our graph, showing that there is order in the way things are dividing. So obviously, there is a pattern of division. There is a structure. There is some geometry involved that produced the division of space. A little bit like Copernicus thinking, imagine being on Earth thinking, maybe if I put geometries together, I can figure out the orbits of planets. Why would that be true, right? I mean, why would some geometry on Earth be related to anything that's going on about the orbits of planets? Yet its solution was 99.9% accurate for the inner solar system.
It still holds accurate, does it not?
Right, it does.
Calculations are still accurate.
It still holds for the inner solar system. And so it was clear to me that finding the geometry, finding how the space is dividing was very important, because that was the key to creation. Mainly that creation, what we call reality, is basically a division of the space. So I started to think, well, if that is true, then it would have to be that the space, what we call the vacuum, what we call nothingness, is actually everythingness. It holds all the information. And so it couldn't be a zero energy potential. It couldn't be nothing. It had to be everything, infinite energy potential. And so I started to study physics intensely and found that actually in our current quantum theory, the vacuum, right, in the space, the vacuum inside the atom, in order for equations to work, has to be almost infinitely dense. It's thought to be 10 to the 93 grams per centimeter cube, which is an enormous number. If I took all the stars in the universe we see right now, and I squashed them all into a centimeter cube of space, I still wouldn't have 10 to the 93 grams per centimeter cube energy density. So in order for quantum theory to actually work, we have to have an extremely dense vacuum. So when you think of vacuum, you don't think of something extremely dense, but actually it's necessary for our equations to work. Now, is that really true that it's there? Now, many physicists for a long time said, well, it's just an aberration of the way we write our physics. It's not actually really there. But recent experiments that was the result of calculations that were done in 1947 by Casimir, which is called the Casimir Effect. Casimir said, okay, if the vacuum is that dense, then it has all these electromagnetic fields in it that is very intensely dense. If I put two plates together very, very close together, I should be able to eliminate the long wavelengths of the vacuum. And so there will be a difference between the plate and on the outside of the plate, and the plate should be pushed together at a certain strength. And he calculated that. But when he made the calculation, it showed that the plate had to be microns apart. And in 1947, nobody could cut two plates with accuracy of microns. In 1947, nobody could cut two plates with accuracy of microns. So it was not possible to put two plates together that close until 1990, where Dr. Lamoureux did it. And he did it first with a ball, because it's a smaller surface, and a plate. And then eventually two plates were brought together that close, and all this. And they were shown to be pushed together exactly at what Casimir had calculated in 1947. So we know that the vacuum density is there.
Basically, that experiment proved the incredible amount of density, theoretically, that in equations should exist in the space of an atom. Mm-hmm. My understanding of that was to hold the atom together requires an incredible amount of powerful energy compressed into a very small area, which is its density. Is that correct?
Well, in quantum theory, it's not thought that way. In quantum theory, what holds the atom together is the strong force, which, you know, is another issue that I resolve in my equations, where I show that the strong force is an aberration of modern physics.
What do scientists currently understand the strong force's meaning?
When the protons were found, they were found to have a electrostatic force because they are charged, right? And they're same charge, so they should repel each other. Just like when you bring two magnets together, they would push against each other, repelling each other. And closer you bring them together, more it will push apart. And so you can imagine that finding highly charged particles all squished in a very small space in the middle of the nuclei of an atom would produce an enormous force. It's called the Coulomb Force, the repelling force of these charges. And so the atoms should have blown apart immediately after the Big Bang. And so that produced a big problem in physics earlier on. And the solution was to think, well, gravity is not strong enough to do the job, and to invent a new force, which was called the strong force. And it was written to be exactly the amount of force necessary to push the particles together against the Coulomb force, which is very convenient. And then, you know, the strong force was mediated by gluons, some kind of particle that is the glue of creation, if you'd like, and so on. And then quantum physics went on with all of its mathematics and elaboration of the atom, never really explaining the source for the strong force, for that incredible force, the source for the magnetic field of the electron, the charged particles, and the spin of all this. So, fundamentally in quantum physics, there is this avoidance of causation. What is causing all this to happen?
This is where we have come to.
Right.
we have to have an understanding of origin that is not existing in current physics, which to my mind is largely based on mathematical theories which are constructed in human brains, which are resolving or attempting to resolve problems after the fact of something existing. Ontology is the study of existence itself. How can a thing actually exist? How can a thing come out of nowhere? And this brings us to the very central, I think, question of where did it all start, which is connected to your exploration here, of course. This incredibly dense energy that is holding the very stuff of creation together has been misconstrued by the very people who are experts in its investigation, who are called quantum physicists.
Right.
Whereas a physicist, per se, is not necessarily involved at that level of creation. So, our view of the universe, which we see is very related to pioneers like Newton and Copernicus, I don't know how closely they investigated origin of matter.
Right. You know, in current standard views, they've replaced the word God with the Big Bang.
Yes.
You know, so if you ask your priest or, you know, your guru or, you know, what made the world, the typical answer is God made the world,
yes.
Right? Well, you know, in science at this point, if you say what made all the atoms in the universe, they say the Big Bang. And if you ask, well, what made the Big Bang, they don't have an answer. So really, it's equivalent to saying God did it. Right, but it sounds more scientific to say the Big Bang, right? So,
very much so.
Yeah. So to me that was unacceptable, and I thought that the key may be that maybe there was never a beginning, never an end, but a recursive cycle of feedback of information, a continuous growth from infinitely small to infinitely big. That nothing could be isolated from anything else, right? That you can't isolate the atom from the planet that it's on, and you can't isolate the planet from the solar system, and the solar system from the galaxy, and so on. And if that is true, then you can't even isolate masses, meaning to say this has a certain mass doesn't consider all the atoms that it's made out of, the subatomic particles that it's made out of, and the infinite possibility of each of these subatomic particles has mass. And so if you add all these mass, you find that every single point in space obeys the condition of a black hole. And so that led me very quickly to understand two things. Maybe our world is just space curving towards singularity, right? And when it does, right, when the space curves towards singularity, it divides in very specific, you could think of it as octaves or resolution. And every time it divides, it produces one resolution that we might call a galaxy or a galactic center, the black hole at the center of a galaxy, a star, an atom, a subatomic particle, and so on.
Well, I see a contradiction here, so I have to go back a step. First, I hear you saying that there wasn't really one Big Bang that created the universe, that it's an ongoing process, but then I hear singularity. So I'm a little bit confused. Let's step back a bit here. Like you, when I was young, my question wasn't really what is this space in between objects for. I heard about the Big Bang, and my immediate question was, where did the Big Bang happen?
Right.
It's a very simple childish question. If an explosion is going to occur, you require an environment in which to explode something.
Right.
It seems perfectly logical to me.
Right.
You cannot have an explosion not happening in no place because there is no defining parameter for an explosion.
Yeah, no, never mind the fact that you need to compress the energy into the space, into that. There must be a compression or a confinement of the energy in order for it to explode.
Yeah, but the space doesn't exist yet to compress it into.
That's right.
You can't talk about space yet.
Right. So you can't have just space exploding a Big Bang.
No.
Right. So the concept is flawed at its origin.
It's flawed at the origin.
Right.
So am I correct then in saying that you do not agree with the current cosmological view that the universe was created from a singularity called the Big Bang? Is that correct?
I would, yes and no. I agree that the universe was created from a singularity. However, I am saying that everything is a singularity, and so that there is continuous creation. It's a continuous creation model.
I see.
It is
a very important model.
Right.
It's a very important model. Everything is the Big Bang still happening.
Exactly. The Big Bang is a little whisper ongoing everywhere in the universe.
So
and
that makes a very big difference.
absolutely.
To everything.
Everything.
Because the current view is we had a singularity, only one singularity, called the Big Bang, out of which was born both space and time, matter, energy, electromagnetism, the strong, weak force. Everything came out of this nothing.
Right.
Everything came out of nothing. We're expected to believe this, first of all, although there is absolutely, we can't say there is no proof. We must be fair to the Big Bang theorists. Their so-called proof, if I can be a bit facetious, because it seems very weak to me, is based on what premises? Explain the Big Bang theory for the layman in terms of what they say.
Well, in general, the Big Bang is thought to be a point of the size of a singularity, which is 10 to the minus 33 centimeters, which is billions of times smaller than an atom. So imagine a point billions of times smaller than an atom from which all matter and energy emerge from. So imagine all the atoms in our universe emerging from a point that is billions of times smaller than the atom itself, right? And so, and from that point, and the support for that view is that we can see our universe is expanding, and so we can, if we turn back time, we would see it shrink back to that singularity. And when we go back in time towards that singularity, mathematically, right? We can
mathematically,
and theoretically, we can produce all the material we see and everything we see. It makes somewhat sense. There's a lot of fudge factors that get put in for it to look the way it looks today, and that, you know, those fudge factors are tremendous at this point. They're getting, because every time another piece of information come in from new observation that doesn't match the Big Bang model, you know, new patches are added, including at this point some 96% of missing mass, you know, dark matter, dark energy, and all this stuff. So, you know, so what I'm saying here is that, you know, the bang that produced our universe is most likely correct, that there was a bang and that it produced what we see as our local universe, right? But what I'm saying is that it's banging all the time. You know, there was a bang prior to that, and there's probably a bang that produced the universe we're in, right, on a larger scale, and then another bang that produced, and it's banging all the time, like a supernova is a star that bangs, and all of a sudden there's a bunch of material available to make planetary systems around that star, right? Our universe banged and produced, you know, a lot of material to make our local universe, but that that's a process that's ongoing and continuous, that space is continuously producing matter. And that starts to explain as well why our universe seems to be accelerating as it expands, right? So, which is against, entropic laws, right? So if matter is continuously being produced, our universe is continuously expanding, but as well as continuously contracting, because, the production of matter is the result of this curvature towards singularity, this result of space moving towards the center, towards the bindu point of creation, if you'd like, the point of infinite density that centers everything, in my theory, that's present at the center of every single atom that you're made of, that every atom you see is a mini black hole, but black hole in a larger sense, maybe written W-H-O-L-E, a point of infinite density that radiates a certain set of information.
Yeah, the terminology black hole is very, very misleading for a lot of people. A good one, bindu point, creation point, emergence point, convergence point. I don't know, there has to be a better word than black hole, because there's a great deal of controversy in the scientific community about, do they actually exist? Our observations strongly suggest this, in fact, is the case. The electric universe proponents, for example, completely deny the fact that they exist, because they said we've never actually touched, smelled, heard, really grabbed hold of a black hole. So it's only a theoretical model. But then, on the other hand, we have these brilliant scientists like Hawking, who's made a very big case for black holes. But before we go into that very delicate area, one step back. What evidence do we have that the universe is expanding? For the average person to understand, they have absolutely no perception that anything is expanding around them at all.
Right.
How do we get this information?
Well, it's called redshift. So we can see, because of the Doppler effect on the electromagnetic field, if an object is moving away from us or if it's moving towards us. And when we look around us in our universe, it seems like everything is moving away from what seemed to be a central point, which would have been the Big Bang.
Seems to be a crucial word.
Right, seems to be, because if we're only able to see a very small portion of our universe, there could be a portion that's expanding while there's another portion that's contracting. And that is my big contingency on this, is that actually the structure of space-time is toroidal in nature, and new mapping of the background radiation is starting to show that our universe seems to be a torus. And so if it's toroidal in nature, then there's an expansion part, like if you rotate a torus so that the edges come out at the equator and back down at the pole. And so if you have this rotation, you have an expansion on one side and a contraction on the other. And the feedback between the two is what I believe drives creation. Feedback between gravity, which is space moving inwards, and electromagnetic field, which is space moving outwards. And the exchange of information drives the learning of the universe, drives actually what I believe is actually self-awareness of the universe, because it learns about itself. It has feedback.
Yeah, that's about 8 steps ahead here. Getting people to that stage of understanding of toroidal form. So let me just back up a bit here with the expanding universe, which is based on background radiation.
It's based on redshift.
Redshift, first of all.
Right.
And redshift was highly contested by a guy called Alton Harp.
Right.
Who said that it is nothing to do with distance at all. He said it's got more to do with actual age of stars. And in recent photographs from Hubble have shown a apparent redshift galaxy that should be billions of light years far away from a different color galaxy on a close-up photograph, appearing to be physically connected by a kind of a pipe, which really throws the whole idea of redshift like yesterday we were talking about radiocarbon dating. It could be extremely inaccurate, and it could actually be plain wrong. So if his theory is true, that the color we are seeing is not a function of distance at all, but he is saying it's a function of the age of the star, and it's not distance, then where does that leave our expanding universe theory? Does it leave us anywhere? Is there anybody else out there in the scientific community that you know of that is actually arguing against the expanding universe theory? Or are most people in unison about this idea?
Well, in general, yeah, the standard model is very popular, that our universe is expanding.
Based on redshift?
Based mostly on redshift and Doppler effect. Yeah. And you know and there's many debates about the redshift. I mean, there's redshift data that shows stars that's supposed to be redshifted to the point where they should be older than the age of the universe itself. Yeah. And so there's all sorts of issues with that. But in general, just based on the understanding that I have of nature, of observation of nature, my tendency would be to think that there is an expansion side to our universe. However, I believe that expansion side is balanced by a contractive side, that there is the two always, that there is an exchange between what expands and what contracts. That you can't, the typical description of the mainstream of our expanding universe is a balloon that's being inflated with pennies glued through it. And the pennies represent galaxies moving away from each other as the balloon expands. But the question I have is, who's the guy that's blowing in the balloon? You need to compress air into the balloon in order for the balloon to expand. And as the balloon expands, the lungs inside the guy are contracting, and you have to put that part of the equation in, which is constantly omitted in our physics. Most of our physics is based on expansion, explosion. We put most of our engineering is thought to be very advanced when we put a whole bunch of fuel in a cylinder. We light the bottom and we put a little capsule on top with volunteers, and and then it explodes. The fuel explodes at the bottom. And that's our idea of the most advanced engineering on our planet, right? But and it's based on entropy and radiation and all this. But actually, if there is entropy and radiation and all this, there must have been centropy. If there's radioactivity, there must have been general activity before that. Things must organize in order to radiate, and so that part, the organizing component, the part that compresses towards the center, that self-organizes, is completely ignored by our standard model, or rarely addressed. And in general, it's thought to be some kind of fluctuation, like, for instance, the fact that our biosphere is so highly organized. I mean, one human being is such a proof of an intense level of organization in our universe. What is organizing the DNA of a human being? I mean, there's enough DNA in one human being that if I pulled it out and put it end to end, I could wrap it around the world 5 million times.
It's a lot of phone books.
Yeah, and that's all absolutely well organized and coordinated, and so that your cells know not to, your toe doesn't make nose cells and your nose doesn't make toe cells, and there's currently nothing in our biology and in our physics that explains why there is cell differentiation. How come cells know what to do and how to do it, and heart cells and liver cells all differentiate and know that they need to be there. So what I'm saying is that when we take this different view, when we start to think of a continuous creation system where there's contraction and expansion, and that these two are absolutely linked together and feeding back on each other, now you start to see that there is a learning structure. There's a way for things to learn about itself. And so there is a further complexity organization system. And I started to think, how is that, what is producing, what are the mechanics of that system? And it started to become clear that if it's organized, if it's continuously creating in further and further complexity of organization, then they must be an agent that holds the information, that knows what everything is doing so that it can self-coordinate. When you start thinking that way, the problem is that the scientists will say, oh, you're starting to fall into religion because you're going to tell me, next thing you're going to tell me is that God is organizing that. But no, there's another alternative, and that is that there's feedback in the space itself. If I asked you to point at something in the universe that connects all things, what would that be? The only thing you could point at is the space. Space is everywhere, in all atoms and between all things. So all things radiate information in the space and then gets fed information back. And so there's this feedback that makes it possible for the space to learn about itself. And you could even start to think of a human being as an extension of the space looking back at itself and learning about itself, like a probe learning for the universe.
Wonderful. Let's take a break.